Hey everyone, our project is exploratory data analysis and prediction of car details. What we are trying to do is we are trying to see how parameters related to car, such as the year in which it was sold, its selling price, the kilometers it was driven, the type of fuel it has, whether it was sold by an individual or a dealer, how its transmission type, and all these parameters affect each other. That is what we are trying to visualize and predict. So now let us go over the implementation. Initially, we first loaded the data from our data set. It was a CSV file that we loaded. This is the structure of our data. This is how the data is structured into vectors in columns. As you can see, most of these vectors are character vectors, but don't worry, we will handle them during data cleaning. After loading the package, loading the data, we first installed some packages that we'll be requiring. So we require three packages: ggplot2, dplyr, and plotrix. The ggplot2 package is used for creating visualizations for the exploratory data analysis that we conducted. dplyr is a package which provides us functions such as select and filter, which make manipulating data much easier. Plotrix is a package that we use to plot a 3D pie chart. Now, let us move on to, now that we've loaded the data and installed the required packages, let us move on to data cleaning and pre-processing. Now, why do we require to clean data? Because on checking the count of columns wherein there was no data, that is the rows which were incomplete, we found out that we had incomplete rows. So we eliminated those rows. And as you can see, initially we had 8,100 rows, but after removing rows which were incomplete, we have 7,900 rows. Another thing that we did, as I mentioned during the structure of the initial data set, most of our vectors were character vectors. And so to create proper graphs, we required to convert them into numeric vectors. So what we did was we converted these values. We truncated the white space and CC out of the string and converted this string of 1 to 4 into a number, and that is how we created the entire numeric vector. The same thing was done for the mileage column, wherein the kilometer per liter and the white space were removed, and this string was converted into a number. Another same thing was done even for the max power column, right? Now, the data cleaning that you saw before this was for the visualizations, and this current data processing is for prediction that we will be showing you later on. So for that, what we did, we first collected the required columns from the data set in one particular variable, and now in the original data set we had the year, right? But we to do prediction on the value, we require the age value. So we just subtracted the year that we had in the data set with the 2020, which is the year in which the data set was created, to get the age. And that is how we calculated the age of the car that was sold. We also had to convert certain columns into binary. That is, so there was petrol and diesel. We converted into ones and zeros. We eliminated columns which of CNG and LPG because they are very few in number. So that is how we converted certain columns into binary. So as you see here, even transmission types was converted into binary. Similar thing was done for seller types, where individual and dealer were converted into ones and zeros. Also, owner types were converted into binary ones and zeros. Now we will be going over the visualization of data, which my group partner Sai Kiran will be explaining.
Now we will have a look at different types of visualization techniques. The first one is the histogram, which is a simple bar graph where we can notice that this one has been used for the data number of seats versus number of cars, and we can clearly see by the peak that the highest number of cars are 4-seated cars. Now the next one is box plot. This technique is now being used for number of seats versus the selling price. What happens in box plots is the small horizontal lines depict the extremes of the values, like the minimum value and the maximum value. Within the rectangle, the middle black portion depicts the median, and the lower and upper edges of the rectangle depict the first quartile, that is 25 percentile, and 75 percentile, which is the third quartile. Now the next one is a pie chart, which is used for a fuel type in this case, and we can clearly see that the proportion of diesel based cars is comparatively more than petrol as well as LPG and CNG. Another form of pie chart is a 3D pie chart, which gives us a different sort of view, and this has been used for the transmission types, and we can notice that the proportion for manual is much greater than that of automatic. Next one is bar plot, which has been used for seller type versus number of cars, and we can clearly see by the peak that it is highest for individual, next is for dealer, and the third for trust mark dealers. Next one is scatter plot. With this case, we have used it for selling price versus the distance driven. In this, we can clearly notice that if the distance driven is less, the selling price of the car is the highest, and noticeably we can see that there is a downward trend which shows that if the distance driven is more, the selling price of the car decreases, and the blue line shows us the median values, whereas the gray portion depicts the error margin of that median. Next one is line plot. In this case, it has been used for selling price versus distance driven. Again, we can see that if the selling price is high, then it is the distance driven is less, and accordingly vice versa. From now on, my group partner Yash will carry forward.
Okay, so the next visualization that we'll be using is the bar chart. The bar chart shows us the distribution of fuel type with the number of cars. For instance, if we take the diesel fuel type, here we can see that majority of the diesel cars are owned by the first owner, and a very small of them are owned by the second owner, and fewer still are owned by the third owner. This graph tells us that most diesel cars have small resale value. Okay. Moving on to the next chart, we have a dot plot. This dot plot gives us an insight on the number of seats that each car has for a particular fuel type. For instance, we take a petrol fuel type. We can see that petrol fuel type cars only have seats in the range 4, 5, 6, 7, and 8, whereas CNG cars have seats in 4, 5, and 7 and 8. Moving on to the next plot, we have a smooth plot. This smooth plot gives us the relationship between engine capacity and car mileage. As we can clearly see, as the engine capacity of a car decreases, the car mileage increases. Moving on to the next plot, we have a density plot. This density plot is between two variables, car mileage and the density. If we take the petrol car type, for instance, we can see that majority of the car types with fuel type petrol have a mileage between 15 kilometers per liter and 25 kilometers per liter, as we can see in the purple peak. Okay. Now, moving on to our prediction, the two variables that we have choose for prediction are engine capacity and mileage. Here we are trying to predict the mileage depending upon the engine capacity. A small introduction on the two variables. Engine capacity is the amount of fuel that a car consumes. Okay, and mileage is the amount of distance a car can drive. As we can clearly see, as the engine capacity for a car increases, the torque that the engine provides on the wheel increases, thus decreasing the mileage of the car. As we can see here, as the engine capacity is increasing, that is, say if the weight of the car is increasing, the engine has to provide more torque on the wheels, thus decreasing the mileage. Moving forward to our next visualization is also a linear visualization. Here we are finding the relationship between age and mileage. As you can see, as the age of the car increases, the mileage of the car only slightly decreases. This tells us that as the age of a car increases, the wear and tear on the engine increases, thus decreasing the mileage of the car. Thank you.
Thank you.